So we are going to pretty much spend the majority of this term on algebra, because there's sort of two big things that we want to do with algebra, and they're in two different units. One is how to use expressions and how to simplify them, and the other is how to solve equations. Those are sort of the two big things in algebra. Okay? Before we start all of this, though, yes, I am recording. It'll be helpful to know some terminology related to algebra. Okay? You don't have to define them. Like, I'm not going to say define this, define this. All I want you to know is if I say refer to the word binomial, you know what I'm talking about. Okay? That's all this is really going to be. One of each, right? Go ahead, tell her. Okay. So what is this algebra thing? Well, it's a big part of math, huge part of math, big part of what you're going to do in all 4 grades of high school math, where we use letters and we use operation symbols like plus signs, minus signs, division bars. We use exponents as well as numbers. Okay? And that's really what algebra is all about. It's how to calculate formulas and how to find missing values. That's really what it comes down to. 2 big things. You guys have been doing algebra for ages. It just was really never called that. Every time you found the area of something, you were doing algebra. Okay? And it's based on the concepts of unknown values, which we usually show using a lowercase letter. What do we call those things? Not polynomial. Not exponent. Variable. A variable is some unknown value. And usually we use a lowercase letter. You don't have to. You can use uppercase if you want. And actually, when we hit grade 11 and grade 12, we're going to use some Greek letters as well. Okay? So a variable is part of something that we call a polynomial. Okay? So a polynomial is basically it's a math statement. And a math statement, using fancy math words, is called an expression. That contains one or more of what we call terms. There's one other thing for polynomial. Because you may see exponents in them, any exponents must be whole numbers. Okay. So a polynomial is an expression. Here's an example of one. This one has 3 terms. Okay. How do you tell terms in an expression? They're the ones that are separated by the plus and minus signs. Okay. So the 3 terms are this one, 3x squared. This one, negative 2x. We have to include the negative if there's one. And this one, 5. So it has 3 terms, 3x squared, negative 2x, positive 5. That's it. And what are terms? Terms are made up of a variable, and this variable might have an exponent, possibly with an exponent, and a number being multiplied. So if you look at this term, okay, whenever we have a number and a letter beside each other, that always means they're being multiplied. Okay, so this actually means 3 times x squared. So it's got a variable, and it's even got an exponent with it, and it's being multiplied by a number. That's a term, which I've just talked about here, possibly with an exponent there. This has got a variable. It's got a number that are being multiplied together. It has to have at least one of them. This is just a number. It doesn't have a variable, but it's still a term. Okay. What are the coefficients called? The coefficients are the numbers in front of the variables that you see. So look at one of the terms, look at the variable. Give me one of the numbers that's in front of a variable. 3. So that's a coefficient. There is another one. Careful. Negative 2. Take the negative with it. So the coefficients are the numbers in front of variables. Being multiplied. The last term in this example doesn't have a coefficient because there's no variable in it. What's the coefficient of that one? You're probably thinking, I'm not sure because there's no number in front. Actually, there is a number in front. We just don't have to write it because it means the same thing. What number? 0? Wouldn't that make the whole thing 0? 1. So if you've got a variable by itself, the coefficient is always going to be 1. Another way we can describe polynomials is by their highest exponents. And when we talk about their highest exponents, we are talking about, and don't confuse this with angles, the degree of the polynomial. Okay. So in the example above, we would say this polynomial has a degree of, what's its highest exponent? 2. Because 2 is the highest exponent in the polynomial. Okay. Each term has a degree. Okay. The whole thing is called degree 2 because the highest exponent that we see in the expression or the polynomial is 2. But, like I said, each term also has a degree. So this negative 2x actually has an exponent in it. What would be the exponent we would write here? We just don't because it's the same thing. 1. X to the 1 means the same thing as x. Y to the 1 means the same thing as y. 7 to the 1 means the same thing as 7. So this term actually has degree 1 because negative 2x is the same as negative 2x to the first. Five doesn't have an exponent. So that means 5 doesn't change at all. 5 is just 5. And if something doesn't change at all, we call it a constant. But you can actually write a variable with 5. 5, think about it, would be the same as 5x to the 1. Well, x isn't, 5x to the 1 would be 5x. 5x to the what would give me 5. Think about it. This has to be 1, right? Like 5 times 1 is 5, so x has to be 1. Any number to the what power is always 1. 0. So any constant term actually has a degree of 0 because 5 is technically the same as 5x to the 0. Okay. Again, you don't have to worry about how to define these, but it's just we're going to be using these words, so you need to understand what they mean. Finally, there's 3 special types of polynomials, because a polynomial could have 1 term, it could have 2, it could have 3, it could have 20, it could have 50. Okay? How many terms do you think a monomial would have? 1. What about a binomial? And try? Right. So what would be an example of 1 term? Well, just pick a number, a variable if you want, and an exponent if you want. So you could say 2x. You could say negative 5y to the 5th. You could just write a number. They're all single terms. Okay? Binomial, you're going to need a plus or a minus sign. Can somebody give me an example of a binomial? 2x plus 2. Got 2 terms, 2x and 2 separated by a plus sign. Give me another one that has an exponent and the letter a in it. Two a cubed times 5 plus 5. Good. Excellent. Terms are separated by plus or minus signs. Somebody want to give me an example of a trinomial? Give me a term. Anything. Whatever comes to your head first. Quick! Plus 2a. Sure. And then plus 8. Remember, we can have minus signs too. So we could have, say, 7x minus 2y plus 1z. That would be another example of a trinomial. So what do we do with these things? Well, we evaluate them. We use them as formulas. To calculate things, we always want to come up with a formula. A formula gives us a quick way to calculate things we want to know. So if we're into construction or if we're into architecture, we need to be familiar with like area, and we need to be familiar with volume, and we need to be familiar with surface area, and all sorts of other formulas that we would use that we're going to see as you guys get into the older grades. Okay, all of those are, any kind of formula is an expression, and also is a polynomial. Like, how do you find the area of a rectangle? No, you don't get to answer. And somebody else is going to answer. Come on. Base times height. So capital A equals little b times little h. What's another way you learned it? Now all of a sudden we're confident. What's a formula to find the perimeter of a square? I'm not sure how to write that. No, no, no. Susie. Side times 4. So perimeter could be, so, and writing it in proper algebra, we don't write S4. We always write the number first, so we would write 4S. Exactly. These are polynomials. You've been using these things all along. Okay? And why do we use these things? To calculate these things. And how do we use them? Well, we plug in the numbers we're given and we calculate. Okay? That whole process of plugging in the numbers and calculating is called substitution. How you doing, Sam? You all right? Having a good day? You're just smiling. Look at you. How's your calculator? All fired up? Got plenty of light? You're okay? Nice. Yeah. You don't have to respond at all. You don't have to say anything. I have no clue what you just attempted to say. Okay. Okay. So these things can be pretty easy, or they can get pretty complicated. So here, what is the value of 5x if I tell you that x is 6? Yeah, you do 5 times 6 and you get 30. So what do? We substitute, instead of x, we replace it with 6 in parentheses. Why? Because that shows multiplication. And 5 times 6 is 30. That's it. Next one's a little bit more complicated, involves a couple of variables. By the way, what kind of polynomial is this? What do we call a 3-term one? Trinomial. Good. So this time, I've got to replace x with 4. And use parentheses, because if you don't use parentheses, you're writing the number 44, which is a big difference than 4 times 4. Minus, and then replace the y with -3 in parentheses. That's 10. And now it comes into one of these questions that we've been working on since the beginning of the year. So what do I do next? Okay. Yep. What can I do with this? Yeah, +3. And then +10. And then I can just do all 3 of these together to get my final answer. 29. Okay. This next one, well, again, the first thing I'm going to do is I'm not going to do any calculating. I'm just going to see, every time I see x, I'm going to replace it with 4 in parentheses. And every time I see y, I'm going to replace it with -3 in parentheses. So on the bottom, I get -3 in parentheses minus 4 in parentheses. And remember how to calculate these. You do everything up top, you do everything on the bottom, you divide at the end. So what's a simple way to write the top? 4 subtract -3, which is the bottom. -7. And therefore -7, sorry, 7 divide -7, -1. Sometimes you may get expressions with parentheses. We actually try to avoid those ones, and we'll talk about how we can get rid of them a little bit later on. But if I replace, so I've got parentheses here, and then I'm going to have to put parentheses within parentheses. So instead of x, I'm going to put 4 in parentheses, plus, instead of y, I'm going to put -3 in parentheses. And then again, you guys know how to go from there. You do what's inside the parentheses first. 5 times, what does this work out to inside? 1. And 5 times 1 gives us 5. Okay? Ooh. Fractions. That's okay. You guys know how to do them. So again, first step is to replace x with 1/3 and y with -9. Well, we're multiplying fractions here. So remember, 6 is the same as 6/1. -9 is the same as -9/1. So what is 6/1 times 1/3? 6/3, which is 2. Just 2. Go as simple as possible. Minus, what is 1/3 times -9/1? -9/3, which becomes -3, but then those become positive. So your final answer is actually going to be 5. Last thing I want to talk about with substitution, exponents. Can somebody tell me what A looks like when I replace y with -2? Like this? You definitely need to put the parentheses. Remember, I said you got to substitute with parentheses. Why is that important? Because of questions like this. Because we saw in the last unit, there's a big difference between -2 parentheses squared and -2 no parentheses squared. What's this work out to? 4. What does B look like? Somebody tell me what to write. Like that? Put parentheses around the 3. Put parentheses around the -2. Exactly, because there's a big difference between those two. Because what do I do first? Do I do 3 times -2, or do I do -2 squared? -2 squared, and you got to multiply that answer by 3. So what's -2 all squared? 4, and 3 times 4, 12. What does C look like? Good. What do I do first? 3 to the third, and then whatever that answer is, I got to multiply it by 2. What is 3 to the third? 27, and therefore 2 times 27. Nice. This one, I'm going to put little parentheses within big ones. So I'm going to have inside big parentheses 3 subtract -2 in parentheses. So I've got to work out what inside the parentheses is and then square it. What is 3 subtract -2? 5, or 3 plus 2. And then we square it to get 25. And we're not doing E because I didn't cover negative exponents. We'll cover it next year. Okay. So that's it. That's basically what we're going to do. The first unit is questions like this, except there are ways that we can make things simpler before we substitute. Like, for example, if I gave you this, you don't have to write this down. If I told you that x is -4, what does 2x work out to? -8, right? Pretty easy. What does this one work out to? What? Right. This is like, first of all, I don't even know what y is because you haven't told me. And I don't even know what z is because you haven't told me that either. All you told me is x, so I could put -4 here. I could put -4 here. Well, one way we can make this easier is combine like terms. I've got 8z's here and -8z's here. What happens to them? They cancel each other out. I have a positive 3y, a positive 2y, and a -5y. They all cancel each other out. I have a -17x and a positive 19x. That's 2x. So really, the answer to this one is the same as this one, -8. It's just we had to do some work to make it easier, right? And there's different ways we can do it to make it easier, which we're going to talk about over the next few lessons. But that's it for today. So for Friday, exercise 5.1. But